As x approaches -3 from the right, as you're approaching -3 from the right, your f of x is 2 of x. Well, 2 times x. Okay, so the limit of 2 times x as x approaches -3 from the right. Just plug in your -3. You end up with 2 times -3, which again is -6. Okay, so these match, so we can keep going. Okay, so if you plug in f of -3, you have to find where that less than or equal to -3 is, which is right there. So your f of x is 6. Oh, -6, sorry. Okay, so if all three of those match, you know 2, 3, and 4 are going to be satisfied.
So you chose the, for the f of -3, you just chose the -6?
Yep, because this is less than or equal to -3. So if it were equal to -3, then that's the one you'd use. Now, if the middle one was less than or equal to -3 is less than or equal to x, and that was just less than, then the 2x would have been your f of x. So it all depends on that equal to. Okay, so they all match. So steps 2, 3, and 4, bring that up, are satisfied. Okay, so we know it's continuous at x equals -3. Okay, so now we do the same thing for x equals -2. We have the limit of f of x as x approaches -2 from the left. So if you're approaching -2 from the left, your f of x is 2 times x. Limit of 2 times x as x approaches -2 from the left. You just plug in your -2. So 2 times -2, which is -4. Uh-oh. Okay, so now you're approaching from the right. The limit of f of x as x approaches -2 from the right. When you approach -2 from the right, that's your f of x. So that's going to be the limit of -x squared plus 3x plus 6 as x approaches -2 from the right. And we just plug it in. So you have -2 squared plus 3 times -2 plus 6. So you end up with +4, so that makes it negative. -4 minus 6 is -10, plus 6 is -4. Okay, so these two match, so we're good. And now we just find our f of -2. Okay, so f of -2, we look for that less than or equal to -2. So that means 2 of x is the f of x we're going to use. So that would be 2 times -2, which is -4. Okay, so again, all three of them match, so that means it's continuous at x equals -2. So they all match. So steps 2, 3, and 4 are satisfied. Okay, so we know it's continuous at -2. So basically this tells us that it's not discontinuous anywhere. So sometimes you may have it continuous at one point and discontinuous at one. You may have it continuous all the way through. You may have both points discontinuous. So it kind of bounces between those three options.
Could you have the equations where it's not like in order too?
What do you mean?
I'm talking about like when you have in the beginning where the f of x is -6 is less than -3 on the very top. Or are those equations, would they be mixed up sometimes, or would they always be in order?
I haven't seen any, but I guess it's possible because I haven't looked at all the questions. I just kind of skimmed through them. But I didn't see any that were mixing up like that. But even if they did mix them up, if you just kind
You
of
get
wrote,
the number one.
yeah, if you wrote that out, it all falls in place. Okay. Continuous at x equals -2.
So what would the final answer be? No discontinuity?
Yep, no discontinuity. All right. So any other questions on this one? All right. Let's do. Okay. Okay, so let's say we have another example. What if we wanted to determine the value of k that makes the piecewise function f of x continuous? Okay, and that's for our f of x equals -2x plus 5 for x is less than or equal to 3, and k plus 3x for x is greater than 3. Okay, so only one value would make that continuous, and we have to find it. Okay, so we only have one point where it breaks apart, so we don't have to worry about the boundary lines, because there's only one, and that's 3. So you know when you're approaching 3 from the left, it's -2x plus 5, or x is less than 3, rather. When x is greater than 3, your f of x is k plus 3x. Okay. Now, for this to be continuous, the limits have to be equal from both sides. For a piecewise function to be continuous, the limits must be equal. From both sides. Okay, so that means the limit of f of x as x approaches 3 from the left. Okay, so as you're approaching 3 from the left, this is the f of x you'll use. So that's the limit as x approaches 3 from the left of -2x plus 5. Okay. So we can just go ahead and plug it in. So that's -2 times 3 plus 5. -2 times 3 is -6. -6 plus 5 is -1. Okay. So we also know that the limit of f of x as x approaches 3 from the right, when you're approaching 3 from the right, this is your f of x. So you have the limit of k plus 3x, clean that up, as x approaches 3 from the right. And again, you just replace your x with 3. So that's k plus 3 times 3, or k plus 9. Okay, so we know these have to be equal. Okay, so that means k plus 9 has to be equal to -1. So if you subtract 9 from both sides, k has to equal -10. Okay, so that's the only way that will be a continuous function. Oops, sorry about that. All right. So any questions on that one?
So just make it match.
Yep. Just gotta, once you find the limit from the left, limit from the right, just make them equal. That's it. All right. Any other questions on this one? All right. Hope I'll leave that up for a second. Okay. Okay, so now we're going to start on the secant and tangent line. Actually, these names have absolutely nothing to do with trig. Believe it or not, I don't know why they picked them, because first thing you think is, oh man, back to trig. Nope. It has nothing to do with trig. Actually, secant means, I think in Latin, secare or secare, something like that, which means to cut. So that's why they picked secant. I forgot what tangent meant. I looked it up once, but completely forgot. But actually it has nothing to do with trig. So the secant line is, to be honest, finding the slope of the secant line is really going to look familiar to you. Okay. The secant line is basically the estimated value, or the estimated slope, between 2 points. On a nonlinear graph. Okay, so let's say if we have give that a little more room. Some random graph will say the graph looks like this. Just any random graph at all. Okay, so if we pick 2 points on that graph, let's say here and here. Okay, so we'll call this first point x. Okay, because it's x units away from 0, so we'll just call it x. Okay, and let's call this next one x plus h. So if you had points 2 and 5, this would be 2, this would be 2 plus 3. So x plus some number h. Okay, so that means this would be your f of x, and this would be your f of x plus h. Okay, so if we were to draw a line through those 2 points, because it's a straight line, we can actually use the old familiar find a slope formula, that the slope is equal to y2 minus y1 over x2 minus x1. Okay. Now in this case, your x2 and your x1 is x plus h and h, and your y2 and your y1 is f of x plus h minus f of x. So that means your slope is equal to f of x plus h minus f of x all over x plus h minus x. Okay, so that's just the slope of the secant line. Now, if you notice here, the x and the minus x kind of cancel each other out. So you actually can also end up with f of x plus h minus f of x all over h. Yes?
Isn't this essentially the same thing as the derivative formula?
Yep. The only thing with the derivative formula is
Tell that.
you're applying limits to a derivative. That's the only difference. Other than that, it's the exact same thing.
So then, could you essentially just take the derivative of the formula? That's what the slope is.
Well, actually, the derivative is the instantaneous
Right.
rate of change, and we're actually getting to that like in a couple of minutes. It's like a real subtle difference between the secant and the derivative.
And that the constants don't go away whenever you take the.
Well, with the derivative, with the x plus h just get
Well, they-
closer and closer and closer.
Right.
So that's when you get the instantaneous rate of change. When it gets so close, you can pretty much estimate where it is. Does that make sense?
Yeah.
Okay. All right. Okay. Now this, either one of these formulas actually, you'll see it called the slope of the secant line or average rate of change. You might see a question that says find the average rate of change between this spot and that spot, or find the slope of the secant line between this spot and this spot. It's the exact same formula. Just a different way of wording the same thing. All right, so let's say if we have this graph here, and instead of having our x plus h here, we decide, we're going to move it a little bit closer. Okay, so let's say if we have, just draw a smaller version of that graph. Let's say this is your x, and let's say we decide to move our x plus h closer. Okay, so where we have that same, well, it's supposed to have been a straight line, but kind of off a little bit. Okay, so let's say we decide to move it a little bit closer. So if we have that graph, this is your x, and let's say you move your x plus h even closer. Okay, so let's say you move it like really, like 1/1,000,000th of a centimeter, as close as you can possibly get it. So let's say you have that. If your x and your x plus h are almost at the same spot, trying to separate that a little bit, then that's going to give you can kind of estimate your instantaneous rate of change, because the distance between the slope is so small that you can pretty much predict what the rate of change is. Okay, so let's just say if you have this slope was 4. Then when you move this one became 3. Then when you move closer, it became 2.5. When you move it closer, 2.1, then 2.0002, and it just gets closer and closer to 2 as you move it closer and closer. You can pretty much just predict that it will be 2. Okay, so this is what you call instantaneous rate of change can be predicted as x of x plus h moves, you can say, almost infinitely closer. to x. Okay, so we'll kind of have examples of both. Okay, and this is also called the tangent line approximation. Yes.
So does that mean that depending on where you choose the 2 points along the x-axis, the
Mhm.
slope can be different?
Yep.
I see.
Yep. So the slope changes as your 2 points move. Okay. AKA tangent line approximation. All right. Any other questions on this one? Okay, so let's go ahead and do a few examples. Okay, so let's say if we want to find the slope of the secant line between x equals -2 and x equals 6 on the graph of the function f of x equals -x squared plus 2x minus 5. Okay. Now the first thing you want to notice is if you have between -2 and 6, that the -2 being the first value, that would be your x value. In the book, they may call it a C, they may call it an A. You may see f of a plus h, the exact same thing. And this would be your x plus h. Okay. Now, in order to find h, remember h is just equal to the distance between your 2 points on the x-axis. Oh, difference between the two x values. Okay. So if you wanted to solve for h, really all you'd have to do, h is equal to x2 minus x1. So that would be 6 minus -2, which would be 8. So you know that h is equal to 8. Because if you line them right up on a number line, if you go from start at -2, you'd have to count 8 spaces to get to 6. So h is just the distance between there. Okay? So we know that our f of x plus h, your x plus h is just 6. So your x plus h is just f of 6. Okay? So your f of 6 is just equal to -6 squared. Bring that negative out a little more. Plus 2 times 6 minus 5. Yep, so you end up with -36 plus 12 minus 5. So f of 6 equals -29. Okay. So now we just have to find our f of x. Okay, here your x is -2. So your f of x is just f of -2. So all we have to do is plug in -2 in our function. So that's -2 squared plus 2 times -2 minus 5. Okay, -2 squared is 4. So that would be -4 minus 4 minus 5. So f of -2 is equal to -13. Okay. So since they asked for the slope of the secant line, we have everything we need right there. So the slope of the secant line is equal to f of x plus h minus f of x over h, which is equal to f of x plus h. Remember, that's just f of 6 minus f of x, which is f of -2, all over your h, which is 8. Okay, so f of 6 is -29 minus f of -2 is -13 all over 8. So that ends up being -16 over 8, which is -2. Okay, so that's the slope of that function between those 2 points. Now, if you change the 2 points, of course, the slope changes with it. But that's the slope for the secant slope for those 2 points. All right. Any questions on that one? All right. That's the slope of the secant line. From x equals -2 to x equals 6. Oh, sorry about that. Yes.
Do an example for the tangent line.
Oh, yeah, we're going to do that one. But we have one more example for this one, then we're going to do that one. All right. Okay, so let's say if we have we want to find the average rate of change for the function f of x equals -2x squared plus 4x plus 4 from x equals 0 to x equals 2. Okay. So average rate of change just means the exact same thing as the slope of the secant line. So you use the exact same formula. Okay, so you have from 0 to 2. So that means this is your x, or some may call it your a, and then the 2 would be your a plus h, or in this case, just stay with x plus h. Okay, so we know that our h is going to equal the difference in our x values. Now you can kind of look at that and see it's 2, but going through the steps. So it's 2 minus 0. So we know our h is equal to 2.